interest between these clinical disorders and political behavior is that one of the themes that runs through my research is that even though we might be living in the same world, we might not share the same reality. So there's some classic studies on this from autism. So this is quite old now, but it still holds. So on the left side, you see the scanning path measured through eye tracking of an autistic person, or the autistic group averaged, and on the right side, a non-autistic group. So as you can see, when non-autistic people look at an emotional facial expression like this, they have quite a stereotyped scanning path where they look at the eyes and then they look at the mouth. They also did some occlusion studies on this where they hit parts of the face, and it turns out these parts are the most important if you want to decode the emotional facial expression. Versus in the autistic group, the scanning path is a bit more disorganized, and it seems to focus on sort of standout features like eyebrow, nose, forehead, so parts that are less salient for decoding the emotional facial expression. So even though those people looked at the same stimuli, they probably took quite different things away from it. So it's the same world, but not the same reality. And I think that's relevant for politics. So I don't know this area that well, but this is what came to my mind. So this is from the Wall Street Journal, the blue feed, red feed, you've probably all seen this, that people's biases get reinforced by these automatically generated feeds where they see very different interpretations of the same world. So also same stimulus, different interpretation potentially. So we can use neuroscience methods to get a deeper insight into when and how these different interpretations of the world might happen. So are they very basic? Are they something that's already happening at the stage of sensory processing, or does it have to do more with later interpretations? So this is the only data for this talk, and it's quite old. This is something that came out of my PhD. So here, during my PhD, I studied children who were born with visual impairment. So those are children who have either no vision at all or very limited vision. So they might be able to see sort of blobs around them, but nothing concrete. What was known before is that a high proportion of children who are born with severe visual impairment show signs of autism. So around 60% versus in the general population, the prevalence is between 2 and 4%. So they have difficulties understanding social behaviors of others, adjusting their own behavior to others, and also showing stereotypes and rigid behaviors, so rocking, eye poking. And to bring that home with an example, one of the children I worked with, she was very musical, was completely blind, and she became quite socially anxious because she thought in the orchestra where she was performing that whatever comment the conductor made was directed at her, even if he was criticizing someone else. So she could not really attribute what was directed at her meant for her and what wasn't. So my question was, is that something very basic about social processing that's different, or does it have to do more with the interpretation? So in order to investigate this, I used an ERP paradigm. So for this, children were presented with auditory recordings of someone saying either, hey, your name, or hey, different name. So it would be something like, hey, Joe, or hey, Steve. So they started with a different syllable, they're matched for the cultural background, and they had the same length, but one was their name, one was a different name, and they're spoken by different speakers. What you typically get when you present someone with their own name is a deflection in the event-related potential called subject's own name-related potential. So this is a more negative deflection between 280 and 320 milliseconds after the onset of the stimulus, where the own name is more negative. So we see the own name condition here, not the control name condition. In red, you see the event-related potential for the visually impaired group, and in blue for the control group. So you can see there in this time window and in the channels of interest that the visually impaired group has an attenuated response. So they are not responding as strongly to hearing their own name. This was matched by their behavior. So this is a questionnaire about communication, You can see different ranges. One is where people with autism spectrum condition would score, this people with Asperger's syndrome would score. The round ones are the VI group, the triangles are the control group. So you can see there's a larger proportion of children with visual impairment in the autism spectrum or Asperger range. And that sort of score correlated with how strongly they responded to their own name. So it seems to be something quite basic about responding to your own name that's different, and it already happens very early after the onset. So very fast response to their own name is different. So that indicates that probably something about a very basic response to that social information. So that's one aspect. This is a planned study, but that also relates to this idea of shared world, but not shared reality. So another interest of mine is loneliness. And loneliness is very much about the interpretation. So you could be sitting alone at home and enjoying a good book, but then you wouldn't feel lonely. That concept is called solitude. So you might actually be enjoying that time being spent alone. On the other hand, you might be sitting at home on a Friday night and thinking like, why did no one invite me to the party? Then you would probably feel lonely. So it's very much about your subjective interpretation of the situation that you're in. So some people tend to interpret their situation as being more lonely, and that's associated with negative consequences like higher risk for anxiety and depression versus solitude. It's not. So this was a planned study where people got either sentences that are related to loneliness or related to solitude, and then some more ambiguous sentences that they could interpret either way. And you could use classification where you see what the brain response is to examples of loneliness and solitude, and then see if people can actively shift their interpretation. We'll see if that gets funded at some point. But what I wanted to focus on, because it relates the most to what might be interesting for you, is a study that I'm currently running. And I wanted to present some pilot results to you, but it's surprisingly difficult to get students through the door. And so far, we only had 2 participants. That was not quite enough. But I'll tell you the general outline and then how I think it relates to politics. So in this study, I'm focusing on autism again, but wanted to get at the difference between a state and a trait difference. And I think that's relevant to politics as well. So most of the time we get participants in from some clinical group, we scan them, and then we interpret any differences between groups as a trait level difference. So we think that if we get them in again, they will show the same differences. So it characterizes who they are or something that's not changeable about them. But that's a big assumption to make. So it could be that whatever difference we're finding is only dependent on the moment, and it might change over time. So what we need to do for that is to have multiple assessments over longer periods to see what's changeable and what's not. And then also what is context dependent and what is context independent. So it might be that autistic people show more characteristic signs if they are in a situation that's more challenging, for example, in a very social situation versus in a more isolated situation. So for this study, I want to get people in multiple times. So we get anatomical scans from them, and then they just sit there and do nothing for 10 minutes, staring at a cross. That's the sort of standard thing. It's very boring, but this is the standard way of how these studies were done, and this is most of what we know about functional brain differences in autism. What I'm adding is that they also will watch a reality TV clip, and that came from a discussion with an autism advisory board. So these are autistic adults, and I asked them, what sort of TV content would you think neurotypical people watch and you find really puzzling? And I said, like, well, reality TV, I don't really get why people would watch that. And I definitely agree. Probably something we can all agree on, but lots of people watch this, and when you watch it, it's actually really difficult to decode because the interactions are very subtle. So first dates, it's often very awkward, but it's difficult to see why it's awkward. You really need to see how people interact with each other, need to decode their intentions. And then you see the sort of humor awkwardness in it. So that's one aspect. And the other aspect is that they will watch a 10-minute news clip. I included this because another aspect of autism is an insistence on sameness and difficulty switching contexts. And these news clips are cut quite rapidly. So there's a lot of topic switches, a lot of cuts where you go from someone talking to then seeing a scene and so forth. But of course, they also have content that relates to the sort of things that you're interested in. So they do that for one day, or after each clip. We not only let them watch the stuff, we also want to see what they thought about while they're doing this, which is not a standard way to do things, but probably important to also know what they thought about. So for this, we use the Amsterdam resting state questionnaire. It's about 60 items. They are quite broad. So it's things like, I thought about others. I thought about things I need to do. I felt tired. I felt comfortable. So they all rate these on a 5-point scale. So we have a broad idea of what they're thinking about during these different conditions. At the end, we also do a behavioral protocol to characterize the sample. And then importantly, we repeat the entire thing across 3 different days with at least a week apart. So they watch different clips from the same categories, and these are all randomized between people. So what can we do when we have these recordings from a lot of people over multiple days? One very basic thing that we can do is so-called inter-subject correlation analysis. So super basic. So we get our structural images, we chop that up into brain regions. We don't need to, but that makes it a bit easier. And we extract the bold fMRI response, so basically brain activity from each of these parcels, and correlate it across people. So that's basically saying how similar is the brain response in that area for this person to this other person. So you would probably expect, because they're all watching the same thing, that basic processing areas are very similar, because they watch the same thing with the same timing. But actually, it goes further than that, that we also see similarities and dissimilarities in areas that are more associated with interpretation. And there are actually some quite cool effects that I think you will enjoy. The first one is homophily. So for this study, they mapped the social relationship of, say, around 200 people on a college campus. So this is all of this. So they asked, are you friends with this person? Are you friends with that other person? And so forth. And then they recruited their participants from that sample. So they knew the social relationships between all of the people in their sample. Then they got them in and got them to watch some video content in the scanner, and then calculated this inter-subject correlation. The closer people were in their social network, the higher the similarity of their brain response. So that shows that people who are friends with people saw those videos in a similar way. And that dropped off. So the less closely connected they were, the more dissimilar their brain response. This was mostly related to area temporoparietal junction and bacteria medial parietal area. So areas sort of related to social processing and to attention. So this would indicate that there's maybe something about how friends see the world similarly, but this is also another sort of trait story, that this is maybe something static that's similar about these people's brains. We can go further with this, and we can see what causes similarities or differences between people. So this is a study in autism again, where again they showed them video and then they looked at the similarity, but they also looked at the dynamics of this. So they looked at when the difference between the groups was the largest, and then went back to the video to see which sort of scenes caused that sort of difference. So again, something that might be interesting for your sort of applications. And lastly, what I told you so far is very much about traits. not so much about state, and it seems very static. So we're just capturing something that's similar or different across people. And this study is one of my all-time favorites. They got people to watch an episode of Desperate Housewives and gave them instructions to either watch it from the perspective of a detective or an interior designer. And then they trained a machine learning algorithm to predict from which perspective people were watching it. So first, it was trained under the instruction and then off-label to see. So here's the distinction that the machine learning algorithm made. So this is its decision boundary. So if someone falls in this range, they would say they were instructed to be a detective, or here they would be an interior designer. So it could distinguish those people, even though it's randomly assigned people, and the only difference between the conditions was that they watched the same video with different instructions. It was possible to distinguish them by their brain responses. So it's not just static, but how you watch a video, under which aspect, can also distinguish or can influence how you process that sort of content. So I thought with that, I had a brilliant idea, something that we can take directly from clinical neuroscience and apply in some way to politics. You can probably see the parallels. So we could do the same thing and show campaign videos and then see if people are distinct, if we can distinguish people based on their political affiliations, and then maybe change their perspective and see if that makes their brain response more or less similar. But then I did some research, which I shouldn't have done. And it turns out that someone has done exactly this last year. But maybe something interesting for you. So this was a group from Israel. Just before the election, they showed left-leaning or right-leaning people, videos, campaign ads, speeches of politicians, and looked at this inter-subject correlation. And they found that, so this is similar brain response across both groups. In red, I think, is the right-leaning group. In blue is the left-leaning group. They found differences by political leaning of how people responded to those sorts of videos. Their main takeaway from this was that it's not only sort of higher level brain areas that are implicated in cognitive control, but it's also relatively more primitive areas, for example, in the insula, which have more to do with processing internal feelings, getting body feedback, and so forth. So that's already all I wanted to tell you, because I thought it would be more interesting to have a broader discussion of how these sorts of methods might be interesting in your sort of application, how we could relate that to some psychological constructs that could be more easily measured through surveys. And if you have some manipulations in mind of how we might be able to change people's perspective and see how similar or different they are.
Great. Thank you, Joe, for this fascinating talk. Lots of insight. Yeah, we'll open the floor for questions. Jakob?
Maybe a short clarification question. Can you talk a little bit more about this inter-subject correlation analysis and what you're actually doing there?
Yep. I'll go back to that figure. So when you measure fMRI, you look for differences in blood oxygenation. So that just happens naturally. And when a brain area is more active, the oxygenation of the blood will change. So that is the activity that we measure with fMRI. So that is continuous. So this is one of these traces that you will see there. So the bold blood oxygen level dependent signal goes up and down over time and relates to the activity of that area. So we get that from one participant. They're watching the movie, say the movie starts here, starts at the same time for both of them. For the inter-subject correlation analysis, you take that activity and you simply correlate it with the activity of the same area from another person. So in this case, it's chopped up into areas that are defined anatomically. It could also be defined in other ways. You could also do it voxel by voxel. But the basic idea is that you correlate activity across participants. So if they're watching the same thing, it should be relatively different. or should be relatively similar. Interpretation is probably well, if you have these different perspectives, they might be different.
Is there like a really cheap version of this study that just uses eye tracking?
Yeah, so in one of the studies, they looked at eye tracking as well, but they found that the ISC was predictive over the eye tracking. But I think, for example, from this Israeli study, what's really missing is the eye tracking, because the simplest explanation would be that people just look elsewhere.
Sure.
But I think you should control for that.
Given that the region, central part region, you can decode eye movements really from that place.
Yeah. But for example, for this study, they also looked at eye tracking and also distinguished the two different conditions. But then the prediction that you get from the brain signal on top of the eye tracking still adds more explained variance to then group these two.
It seems like, I mean, if you know, if people have already shown that you can disambiguate people by their views, by the reasons of the correlations, and the next step to examine like perspective taking, like they're doing this study.
Yes, yeah, that's
I mean, in the limit, you could presumably use neurofeedback and try and get people from one political persuasion to learn to adopt the brain states of people from another political persuasion and see if that has a durable effect on their views.
yeah.
That'd be exciting.
Well, I think the most basic thing needs to be done first. But this is just observational. But I think what needs to be done on top of it is to see, can you actually watch it like someone who's from the opposite political leaning?
Yeah.
And then maybe, yeah, neurofeedback would help to change it more completely than, well, there's no open question if this is more similar if you take the other perspective or if you're doing something else when you're trying to do this.
Yeah, great.
Thank you so much. It was super interesting. One question that also Bert and I have been thinking about a little bit lately is, and I just want to hear your opinion on it, is with these dynamic tracking studies and with ISC, when we do predictions, for most of the studies that I've seen, we typically take the mean activity or the mean ISC doing a clip to predict some subsequent rating. How much did you like this character or politician and whatnot? And I just wonder, do you have any thoughts on this? Have you experimented with some other essentially aggregation function that, I mean, we could go back and look at the content and say, is this one moment in time more predictive of the rating than the other? Because I think the average is just a very poor representation when we think about how maybe it was the most shocking moment or the least shocking moment or just the most recent or the first. Have you thought about this?
Yeah, so I think, yeah, there's just so many things you can do with ISC. Yeah, the aggregating across the entire time is a possibility. The other thing I'm doing is to look at aggregates through the different conditions and then see if that makes a big difference. So these different conditions that would be sort of block level.
Mm-hmm.
But then I think it's also important to look at the time resolution. So like how they have done exactly at what time does the ISC diverge. And then you can maybe relate it back to the clip and then maybe create content that would make these differences bigger.
Gustav.
Yeah, so precisely about this, are these divergences found by using multivariate pattern analysis, or is it just by reducing the resolution so you may find any really small window that is significantly different?
Well, I guess you could use MVPA if you look at, so you would need to train it on something first, so you could maybe see what the representation of a certain political leaning is or a face is, and then could decode it over time. In this case, it was really simple. They just looked at group level ISC differences and saw where they are maximum. So
Okay.
it's sort of
Yeah.
lowest, simplest level.
Right.
Quickly, okay, that's okay. I thought it was pretty interesting what you said about this study with the detective and the decorator. So maybe I misunderstand, but so the goal there is to imagine you're this person, and we watch this this video clip. But did they ask this in this political study as well?
No,
Okay, so then my question is, do you think the results of this decorator versus detective study would be actually the same? If we compare it to a study where we say to left-wing participants, now imagine to be a right-wing person.
I think that's an open question. I think it would be an interesting question. So I think it's two possibilities. Either you get the same sort of brain response that you find for a native left-leaning person, or they do something different.
Yeah.
And I think that would be quite interesting.
Okay, I have
Yeah.
a question as well. I was wondering about the ISC that was higher among friends, you said, right?
Yeah.
So essentially, of course, you immediately start thinking about sort of the hen-egg problem here, right? Do we select people with similar brains, or does my friendship with somebody and possibly even discussing first dates with them shape my perception of that? So what do you think would happen if you controlled for the duration of friendship within those? Could we then disentangle if it's somebody being friends with someone making their brains more similar, or do I select people with similar brains or similar brain activities just by default?
Yeah, I think the duration of, because you're open to choose your friends, and you probably, like, even on behavioral characteristics, you choose people who are more similar to you, similar backgrounds, similar personality traits, and so forth. So I think maybe you need to force someone into a friendship and then see if that changes, or expose them to other thoughts and see if that makes them more different, similar. It seems to be something relatively stable. There's another study where they mapped the social relationship of an entire village, and then also looked at the similarity, not while watching something, but just at rest. And even at rest, they could predict who was closely affiliated with whom across this entire village.
How well? I mean,
I don't remember, but quite well. Well enough that I made it into PNAS.
that is a very low bar on that, right?
They're AAAS members. Yeah.
Okay, immediate follow-up, and only like closely affiliated, does that always mean liking and friendship, or could that be a mere exposure effect as well?
I don't think we can disentangle from that. That would be interesting to know. So that, in this study, they just asked people who they're friends with, but not if they actually liked them.
Yeah.
But that, yeah, would be important to. Well, that would be interesting for politics, I guess. If you could try to map your friends who have different views to you, if you're then similar as well, especially when you're watching political content. That'd be really cool.
Or even out groups that you're forced to be in contact with, something like that.
Yeah, interesting.
Derek?
Yeah, thanks, Joe. How do I need to interpret this ISC? Like, how similar is similar, or how high is high? Like, is if Gustavo and I are watching the same thing and we get a correlation, does that mean like our brain is 100% the same in that area, or is it tiny similarities? Because if I understand the deviations here, that these are these I'm not sure if I understand the y-axis here, but I mean, can you say like what is the size of this synchrony, and how substantive is it then?
I don't think the absolute size makes that much. Is that interpretable? Because it also depends on measurement noise.
Yeah.
So, like, if you're extremely highly correlated, don't think you would say, well, this means you're biologically identical.
Yeah.
It's more the relative. So you definitely find more similarity in sensory processing areas, which makes sense because you're watching the same thing with the same timing. For other areas, it's more variable.
Yeah.
You can also look across different time scales. I think what's more important is the relative comparison. So are you and Gustavo more similar than compared to someone else?
And then compare the magnitude of that.
Yeah.
Matthias?
Thanks. Yeah, I was also thinking about the study with the detective and the decorator, and also Gijs's question about how you can apply it to politics. And I was wondering, of course, it will be difficult, right, to ask a left-wing person to take the perspective of a right-wing person, because that just, yeah. But maybe what you could do, some tricks maybe, is to try to make people empathize with one of the two, or try to make one of them look like someone who is really close to someone. So you ask a couple of questions, and then you say, well, this candidate here You only show a picture or something and give some information. It's really very much like you, different in this way and that way. And then let them watch, and then they discover maybe that they disagree with this person, but they might feel that they are very similar to the person, or they might empathize with that person. And that might then also, to some extent, already do the trick. And then you don't have to make people take the perspective of that other political side, which might be too difficult to accomplish in some cases.
Yeah, that's a cool idea.
I mean, it would be a slightly different question, and it's more about empathy maybe and being close to someone. But
yeah, that's something that I was wondering in general when reading that Journal of Neuroscience papers I had on these questions. So the brain areas that seem to pop out across all these similarities, it's always the temporal-parietal junction, which is associated with theory of mind mentalizing and so forth, and also in this political comparison. So I think relatively basic question that you probably addressed already is, to what degree is mentalizing important for political affiliation? So is it people who are less able to take other people's perspective who are at the more extremes of the political spectrum? Has someone done this? No?
Well, I mean, there is this work on people taking the value system of others, but it's not in a political context, it's in an economic context. Right? So these studies where you ask people to imagine that they have a discount function of an individual, a very different discount function in response to temporal choice. Right? So imagine you're an impatient person. How would you decide between £100 now and £200 tomorrow or something like that? And if I recall correctly, so in those studies, when you take the perspective of the other person, then what you see is a kind of gradient whereby, kind of your own values are represented more ventrally, prefrontal cortex, and the values of the other more sort of dorsally in the prefrontal cortex region, which is, of course, exactly the region that is one of the regions implicated in autism as well. So you might imagine that if you do that perspective taking thing, then you can see something, but presumably people's ability to take perspective of the others will be related to that region, I guess.
Cool. You just have to relate it to their political views as well.
Okay. Did you have a question? Yeah.
Yeah, so in that study about the detective and decorator perspective, in both situations, you're asking people to, in some way, shape their perspective to somehow also mentalize, because you're not just being yourself, now you're also being a detective version of yourself. And as a decorator, you also mentalize to some degree. You're thinking from the perspective of a decorator, but also you may be thinking, why did that person choose to decorate that house in that way? So in both situations, you're activating perhaps some sort of mentalizing path already. But I'm not sure if in that study they also tried just letting people watch without any manipulation to see how, let's say, more in a restful state versus in a mentalizing state, what would be the major differences? And I'm pointing this out because, at least based on a lot of studies, maybe they're a bit outdated at this point, but the ones about about cognitive empathy and affective empathy, some of these also about psychopathy, what they often show is that there are different paths within the prefrontal cortex that seem to be differentially activated if it's for mentalizing tasks or if it's more like affective empathy tasks. And in some traits of psychopathy, they seem to show in individuals with higher psychopathy that they use more the mentalizing path than the affective empathy path. What I was wondering is, would individuals that are not prompted, not framed in any way, have a tendency to use more the affective empathy path when seeing something political? But if they're asked to try to pretend or to think from the perspective of the others part of the spectrum, if they would use more the mentalizing path. But the results that you show, because they're based off mentalizing tasks, maybe they don't show any differences on the level of prefrontal cortex. So I just wondered if you think this is really a nice region to look into.
Yeah, that sounds like a good possible research question, if it's different mentalizing paths that are activated. But if you watch it unconstrained, I guess you would bring your typical way of approaching it in. So some people might naturally watch it with more one type of empathy than the other. For the political one, I think that would be interesting to do. Yeah.
Yeah, it's the idea with the perspective taking for the to just apply it to political content, or to apply it to a context where people have a pre-existing perspective and then manipulate this perspective?
I guess,
just thinking
yeah.
Because if it were just political content, we could also use a political topic where that's kind of novel, or where it's kind of ambiguous, like who's for like this new data regulation thing and who's against it, and then just manipulate the sender or the source of the opinion about this particular topic. If it's not important that people actually have a pre-existing perspective on the issue.
Yeah, that could actually be combined. So that would be a little bit like my loneliness study, where you could first have things that people already have an opinion on, and then have something more ambiguous, and then ask them to frame it in one way or the other, and see if that is then more similar or more different.
Yeah. I have another question on the stimuli you used in terms of the reality TV and the news. How many different items did you have per battery, or how many different videos? Because I can see how they differ in terms of how quickly the information is shot at you and how subtle the awkwardness is. I see that, but it probably differs on so many other levels as well, right?
Yeah.
So how many videos do you need in order to somehow bring that to an average, where you really think it's about these differences?
Well, this is not the purpose of this study, and I think there's different trade-offs. So you can have a perfectly controlled study. The standard way of doing fMRI for the last 20 years was to show carefully controlled stimulus, and then something else, and then another carefully controlled stimulus with the exact timing. You control all the low-level things. So like I've done face processing studies, so you control for the luminance, you control for the shape. Yeah, you can control for the exact arrangement of the elements, that they're all the same, and the only thing that might differ is the facial expression. So then completely controlled, but also very far removed to what people see in everyday life. On the other extreme, you have completely unconstrained naturalistic stimuli that differ along many, many different dimensions. In this case, I only see them as blocks. And I use some machine learning stuff to get particular things out of this, like faces and transitions, but they're not carefully controlled, and they're deliberately not.
So you used machine learning to get faces out of this, meaning you took the faces out, or
no. So you can get automatic annotations for these. So you can feed that through a trained algorithm to say at which frame did a face first appear and how long was it there for.
Right, okay.
And then you can look at the face-specific activity and contrast it with something where an object was shown.
Right, okay.
But it's they're naturalistic and unconstrained.
That makes more sense.
Yeah.
Yeah.
I still have a question about that study design.
Yeah.
You presented this super extensive battery of questions asking people what they think about watching this stuff. What do you actually use that for? Do you use that to screen the participants, or do you use that as controls, or?
So far, all these autism studies. So there was a meta-analysis from last year where in the end they had over 1,000 autistic participants doing something like this. And this how we know about functional brain differences between autistic and non-autistic people. So you stick them in the scanner for about 10 minutes, either with the eyes open or eyes closed. They do nothing, and then you compare the brain activity between them and a control group. Now, I think there are various things that you can criticize on this, and one of them is that autistic people might actually experience this entire thing very differently. So that they're in a very loud environment that's very different to what they're used to. There are common sensory sensitivities in autism. So just how they experience it might explain any difference that you see at the brain level. Also did a study this year with some internship students where I just asked people to sit in front of their laptop for 10 minutes and then report what they thought about. And it turned out that autistic people systematically think about different things. So they said they thought less about other people, they thought more about themselves, and they reported having busier thoughts, so more changes between thoughts. So just at rest, doing nothing. And then if we see a brain level difference, is that because of the content of what they thought about, or is it some sort of intrinsic difference of how their brain functions? well, probably the two are related in some way, but still, what I want to get with this is a very broad difference in the content of thought between the autistic group and the non-autistic group, or even some autistic people. So did they think about different things when they're watching this, or when they're resting, or when they're watching that?
Just a quick follow-up to this. So do you know from your research that what you just also said, that autistic people are more dissimilar to other autistic people than to the healthy controls?
Yeah, so there are some studies that came out in the last 2 years, and they say that the autistic brain is more idiosyncratic. So there's more individual differences among autistic people than among. So there's probably some optimal configuration where most typical people sit. And if you're autistic, you might be somewhere out of this. So it's called the Anna Karenina principle.
Yeah, exactly. That's just what I was kind of.
Yeah.
Okay, I'll squeeze myself in because I also have a follow-up. Sorry, it's position of power. So what were the specific instructions for reality TV and news? Because you kind of came at it thinking that autistic people were probably going to be less engaged in the reality TV portions than other participants, right? So did the activation still differ from the complete resting state? Because I could also imagine that if you're forced to watch something for 10 minutes that you really don't enjoy, you just withdraw.
We don't know yet. Yeah, we don't know.
Did you were you sure that they had their eyes open the entire time?
Yes. So
Okay,
we
that
have,
at least.
we
Okay.
have passive eye tracking in
Okay.
there. For the active eye tracking, it's too much math. But we know if they're watching it, and we
Okay.
can also see if they move more and
Yeah.
some of these things. And we can get from the ratings, like there's one in there that says like I felt uncomfortable, or had pleasant feelings and so forth. So we can check that.
Okay. Thanks. Right.
Yeah, thanks. Joe, can you say a little bit more about what do you do in terms of design? So you have autistic people compared to normal,
Non-autistic.
non-autistic.
Yeah.
And do you match them? So how do you make sure, like, is it autism or other related things that like, how do you attribute it to autism?
Yeah, so the control group or comparison group is closely matched. So they come from the same population. We're measuring their verbal and non-verbal IQ. We get their strengths and difficulties. So this is an indicator of various things, like if they had learning problems, if they have mood problems, and so forth. For the non-autistic group, we exclude anyone who has a diagnosis of autism, of course, but also who has a close family member with a diagnosis of autism, because there's a broader phenotype. And they also will not have ADHD because that's highly comorbid. And then no one who's currently having treatment for any mental health disorder or is taking medication for that.
And the problems recruiting is on both sides, or is it?
It was just a long setup. So it might not look like much, but it's quite a complicated setup. And there's so many rules and regulations, and getting that going now at a new research center, it just took a while to set up. So we are getting people in. We have 2 scheduled for next week, but it's just 2 weeks later than I would have liked. Otherwise, I could have presented you some preliminary data.
Just a quick, where do you get the autistic people? Do you work with an organization, or is it like?
So I'm affiliated with the Dutch Autism Research Center, but actually the prevalence is high enough. So if you assume sort of 4% prevalence, there will be a lot of students with a diagnosis of autism. So yeah, we can recruit them from the student population. Because it will be so I'm going for deep sampling. So it's a small sample. It will be around 20 people maximum, 10 each group, but then scanned a lot of times.
Yeah, right.
So individual and deep samples.
Okay.
Nice word.
Tyson and Josh.
Yeah, I want to come back to a point raised by Linda a while ago about the distinction between highly controlled treatments and the more ecologically valid ones that you show here. My question is, to what extent can political stimuli be highly controlled? I mean, the Israeli study doesn't seem to be highly controlled at all. There's a lot of stuff going on. If we strip away that, we strip it, for example, towards a sentence that betrays a specific position. But still, if you do that, there's still so much going on, I guess. There's a specific linguistic formulation. It might echo in people's moral values, but it also stimulates processes of empathy. And of empathy, we actually know that it can have two completely opposite effects in relation to politics. The empathic concern path would polarize more than the perspective taking path, which would do the opposite thing. So even with a very basic sentence, I still wonder how much we've stripped down all the different components, and we can really say, well, this is the ideological position that's causing this and this response.
Yeah, so that's my 2 pence on this. You can't control everything with naturalistic stimuli because then they would be artificial again. But you can control for some confounds that you think are most important. So for example, for this, with my bachelor's group, I ran an online study with the stimuli and asked people to rate them. So you can control popularity, so how many times has this been watched out in the real world, and you can think they're comparable on that level. You can get the sample to rate them on some other dimensions, so were you bored by this, or how much did you enjoy it, and then match it on that as well. So you could maybe look for stimuli that differ in ideology but are similar in engagement. So you just do that in an online study with a large sample before, and then on your small imaging sample, you use those relatively more controlled stimuli. They're still naturalistic.
So, excuse me. So what do you think could be some potential sources of variation in group interpretation? So what I have in mind is maybe a strange example, but I recall this one time when I was watching a movie called The Hitcher. Have you ever seen it before? Nope. It's this horror movie from the 80s. It's about a guy who's driving along in the desert and he sees another guy on the side of the road and he picks him up, and he turns out to be basically evil incarnate. And the entire movie is just an ongoing life and death struggle between this guy who's trying to do the guy who picked him up.
I know what to do tonight.
And I walked away from the movie firmly convinced that the guy that he picked up was some kind of very powerful supernatural entity. And I pointed to things in the film that I thought were evidence of this. And my friend said, no, he's just that good. But he's my friend, and of course, maybe we might be inclined to think that we should have different or similar takes on these things, but obviously there's variation there. So I'm just interested in what you might think might be some of the reasons why that is.
Ooh, that's no idea. But you could do some things with these methods. So you could look at eye tracking. Maybe you looked at different things. You paid more attention to some things that might lean towards the supernatural interpretation. Your prior beliefs might be important as well. So you could ask before, like, how likely are you to pick a supernatural explanation for anything? So yeah, it could be different sources. So your prior beliefs or what you paid attention to is my sort of hunch. Not very satisfying.
I think presumably your values, the way you value things. So brain bold signals are really, really responsive to your valuation. So presumably you value, if you are from a liberal context, then there's going to be certain events, stimuli that you're going to value differently to people from a conservative context, and that'll be detectable in bold signals in valuation network. So that would be a really good way to think, and that of course overlaps with these reasonable considerations.
Yes, but would that apply to the hitchhiker supernatural explanation?
But it depends how much you value supernatural hitchhikers.
Yeah. Well, yeah. Values or beliefs.
Yeah, I do have a really simple question, but I just want to chime in quickly. What's no, it's just something that often occurs to me is that whenever I watch a movie, I usually have more moderate opinions and usually a bit more positive. And then some people will go like, I hated it. And I'm like, okay, why? But this happens a lot. And I think people just look at different things. They expect different things. They have different values, just a lot of individual differences that probably going to come for this. And the question that I did want to ask is, did you did you just look at diagnosis of autism or symptoms of autism as a collapsed score, let's say? But did you look at the dimensionality of it or as a continuous measure? Because like I think in fMRI, usually you prefer to look at categories, or I mean, in a lot of neuroscience, you prefer to look at categories because it's easier to visualize. But in autism, like some research is now moving towards looking at different dimensions and also looking at the continuous scores. Do you think it's easy to do in this type of research?
No. That's good. Well, you can, but you would need absolutely massive samples for this. So some like the ADOS sample with thousands. There you can do that sort of dimensional thing. When you're working with small samples, you want to maximize the behavioral difference. So that's why I'm focusing on diagnoses, but I'm also getting a relative score. But there, in the autism field, there's a lot of debate if the continuum is not an artifact in how we measure it. So yeah, one thing or the other, but with these sorts of comparisons, small sample is better if you have a massive behavioral difference, even if it comes from an underlying continuum.
Great.
Joe, you said something, 4% of the people have autism.
Mhm.
You've reached out to all sorts of ways in which some of the work could be relevant to politics, but with such a sizable group of the population, should we also not be studying how people with a disorder like autism process the political world?
That would be very interesting, yeah.
And in what particular way do you think they would differ, right? You showed some things about like facial processing, but what would be other ways in which, and I'm not thinking per se about worse, but maybe better, like are they maybe better democratic citizens in some dimensions than others?
Yeah, it could be. So I think mentalizing would be one thing, so it might be more difficult for at least some autistic people to take the perspective of someone else. Then there's this cognitive flexibility thing, so more probably less change or less reconsidering, so more sticking to one point and not diverging from that. On the other hand, there's also this neurodiversity movement, so it might be more similar to other minority groups that they hold more liberal values possible. I don't know. So yeah, and for mechanisms, so one thing that I found in the last year that I found very striking, I did these surveys about movie enjoyment in autistic people and people with ADHD. And in the autistic people, regardless of which movie, and they're all sort of similar popularity on IMDb, they rated them as worse. So it seems to, well, maybe some sort of value thing again, that there's an expectation that things are worse or they're remembered as being worse. So maybe there's more political disengagement because of that, but it's very suspicious.
I have a question on the connection to ADHD. You said that you were excluding ADHD due to the high comorbidity to autism. Or do you also expect specific differences in how stimuli would be processed, or for example, then also in connection to how politics are processed? Because I think the prevalence of ADHD is still higher than of autism, right? It's more common. So would that be even more relevant, or are the differences less than to non-ADHD people? Yeah.
ADHD is a lot more common, probably arguably a bit more like a character trait. It has very high comorbidity with autism. So more than half of the people with autism also show signs or would meet criteria for a diagnosis of ADHD. But the mechanisms might be slightly different if you have a comorbid group versus a pure group. For the political leaning for ADHD, I'm not sure because it's such a broad thing. So it would be like saying extrovert people are more left or more right. It's like it depends on probably lots of other factors as well.
Oh, I think that research was conducted, right? Yeah. Okay, but interesting. So it was mainly the comorbidity and therefore the probability of undiagnosed autism why you excluded it, or okay. Okay. I think that concludes it. Thank you so much again for this very interesting talk.
Thank you very much.
And as is custom in the lab, of course, you get a politics mark. So thank you very much.
I will cherish it.
That's good to know. So next week we will have a politics lab meeting. We have a very promising lead on an interesting speaker there, so it might be self-capturing. But you will definitely receive an email about this, and if you're on the email list, and yeah, so we will send around who will give the lab talk next week. So thanks all of you for coming.
Thank you.